Okay, today's book is going to be about Deep Simplicity by John Gribbin. Going to be discussing the main things that we can learn from the book and how we can apply it in everyday life. So, first of all, I have to be honest and say that the book, for me, was good, enjoyable, interesting, but I actually knew quite a lot of the subject matter from previous books that I have read. So for me, wasn't a steep learning curve because the main concepts and ideas I was already familiar with. I actually decided to buy the book and read it because it was recommended by Charlie Munger. I also bought a few other books that he recommended and will be reviewing those in the future. But the main topic discussed in the book is chaos theory. Now, if you've seen Jurassic Park, this idea, this theory, chaos theory, comes up in Jurassic Park. There's a character in the famous film who talks about chaos, and he explains what chaos theory is in one of the scenes, famous scene in the film. But essentially, chaos in everyday usage, when people use it in everyday life, they mean disorder, anarchy, uncontrollable situations, destruction. For example, in the film Batman, The Dark Knight, the Joker is associated with chaos. I think he calls himself an agent of chaos. He goes around and he's constantly destroying things. And Batman, who is kind of his opposite, is seen as an agent of order. He kind of puts order into Gotham City. He is going around and defeating crime, defeating the negative agents which cause disorder, and trying to put in place a rules-based system. That film is brilliant because it's got a really interesting interplay between chaos and order, and the two main characters, the two antagonists, are representatives of these two ideas. Similarly, Jurassic Park is all about chaos and order because in that famous film, a wealthy person has decided to build a theme park on an island, and using clever DNA trickery has managed to bring to life dinosaurs using DNA from millions of years ago. And so he's building this theme park in which people can go around and see different dinosaurs. But this mathematician in the film, when he arrives on the island, is very skeptical, and he says to him, "You're trying to control things. You believe that you have control of the island." They put up electric fences, for example, and have various control measures to prevent the animals from getting out of control. But this mathematician is skeptical. He says, life will find a way, because they try to put in one countermeasure to stop the animals from breeding by having all of the dinosaurs female. But this mathematician, a chaos theorist, he says, life will find a way, which is what happens later on down the line. And the cause of the animals getting out, of the electrical fences being turned off, is another guy who wants to make a lot of money, and he is essentially trying to steal research. So he turns it off in order to try to steal. And this is what's going on. So they believe that they have control, but there are improbable determinants. There are little factors which can get out of hand. And one of the big takes, I believe, from this book is that, things rarely go according to plan, And Nassim Taleb spoke about this in all of his books, but notably The Black Swan. Things don't always go according to plan because there's always tiny factors beyond not only our control, but our ability to see the kind of unknowns and the unpredictability. So when mathematicians talk about chaos, they're talking about systems which, if we understood fully, would be predictable. But it's that inability to fully know every little factor, every possibility. And in the book, Deep Simplicity, he talks about how this might actually be an impossibility. The example given is in trying to calculate the length of the British coastline. And this is a famous example of how, if we use a 30 centimetre ruler, we would place that 30 centimetre ruler and we'd have to go around to the coast of Britain and we'd calculate how many roughly 30 centimetre rulers can we place one after the other to get an accurate estimate, an accurate number for how long the coast of Britain is. But what about if you wanted a more detailed length, if you wanted a more precise figure, and you took the measurement apparatus down? Let's say if you went to the level of the atom and you fully mapped out every nook and cranny, every little crack in the rocks, you would get a very different answer. You wouldn't even need to go down to the level of the atom. Even if you went down to, say, 1 millimeter, you're going to find lots of little ridges, cracks in the coastline. And then, of course, you have other issues here. So what would you define as being the coastline? Does the sand count as being a part of the coastline? What about if you have a rock that's not quite connected to the mainland, that's a little bit out into the sea? Is that the coastline? You get all of these complexities. And the author of this book says that you always get these little complexities, little things that when you zoom in, you regularly find. And it makes making predictions extremely difficult. The classic way chaos theory is demonstrated is when it's using pendulums, and you can start, so swinging pendulums, if you have 3 or 4 pendulums, if they start at exactly the same point, their pathway is exactly the same. They would oscillate, they would swing back and forth until they all stopped at precisely the same time. The problem with this is that you would have to start the pendulums at precisely the same point, and this is nearly impossible. You're always going to get 0.0000001 millimeter difference. And you might think to yourself, well, who cares? That's only 10 zeros, 1 millimeter. But what chaos theory shows is that those little differences become greater exponentially over time. This is known as the butterfly effect. Not only this, but there will be slight temperature differences in the air. So where pendulum 1 is swinging, there might be a very slight variation in the temperature or the air pressure, or the dust, or a fly might land on the pendulum. That could be the black swan that Nassim Taleb talks about. Even if you say that all of those external factors, external possibilities are kept in check, let's say they're all equal, you would still have to start those pendulums at precisely infinitely. The point is that it has to be an infinitely the same starting point, because the difference of 0.0000001 after maybe 20 oscillations is going to be noticeable. You'll see the pendulums depart from the same movement, from the same trajectory, the same pathway. They're going to differ. Lorenz was the first person. There was a weather forecaster. He was a mathematician, but he was working as a meteorologist, and he discovered chaos theory, the butterfly effect. And it's called the butterfly effect for two reasons. Firstly, he wrote a famous paper with the title, "Does a Butterfly Flapping Its Wings in Brazil Cause a Tornado in Texas?" And also some of the shapes, which are absolutely beautiful, which you get from attractors. This book talks about attractors because in chaotic systems, it seems that movements, oscillations tend towards fixed points or finite points called attractors. But don't worry too much about that. You can learn about that if you want to read the book. The main point is that tiny little differences in conditions, in initial conditions, manifest greatly, exponentially over time. And this is why things rarely go according to plan. Because in the real world, you can't get rid of those tiny little factors. The real world is full of asymmetry, complexity, and for this reason it's unpredictable. Because the number of invisible things that can happen beyond our control, beyond our knowledge to even see. He talks about examples of this. So one is that the meteorite that crashed into the planet around 70 million years ago, wiping out the dinosaurs, that particular event, that asteroid, may have come from the asteroid belt in between Mars and Jupiter. In the book, at the start, he talks about how it's very difficult to predict the orbits of planets over millions of years because of the gravitational pulls and tugs caused by the large planets Saturn and Jupiter. So we can roughly say where planet Earth will be in its orbit around the Earth, but we can't know for sure because there are lots of little factors which over time escalate and grow. So it's almost impossible to know precisely where the Earth will be, or any of the planets, because all of the planets are affecting each other. And this is called a dynamic system. But the main point of the book is that, so therefore there's a difference between how things will work in theory, how perhaps many economists predict and think things will work out, and how things work in reality, how things work in practice. Because reality is full of uncertainty caused by tiny little variations in the structure of the world. And therefore, this might be a key reason why Daniel Kahneman wrote about planning fallacy in his book. This is the tendency of humans to underestimate how long things will take to get completed. An example of this, again, in the real world might be HS2. HS2 was discussed around 20 years ago. You know, they were talking about having a train line, and it's been delayed, and the cost has grown considerably, again because there's been issues that have arisen that they didn't foresee. And this is an example of a chaotic system. And there are so many things like this. So he talks about a range of phenomena in the book related to chaos, but I would say it's an important idea to understand, because naturally the world around us, the world we operate in, is not like the world written about in textbooks. There's a lot of complexity, and it's important to understand, you know, because Nassim Taleb also wrote another book called Anti-Fragile, where he suggests that a good way to operate in the world is to position yourself so you're taking advantage of chaos and uncertainty and unpredictable movements. You can position yourself so that you gain in some way. Because if you're not aware of this, then you could be constantly at the mercy of events and circumstances. But being a bit more aware that the nature of reality is so much more interesting than, you know, a merely abstract or theoretical description it's more interesting than physics formulae might imply, because of these strange factors which can affect and influence. Talks about entropy quite a lot in the book, saying that life really is negative entropy. There's an example of negative entropy, and in the last few chapters he talks about how the discovery of life on other planets might be discovered by looking at finding evidence of negative entropy, suggesting that there's a interrelationship between the planet, the non-living thing, and the living things which live on the planet. He spends quite a lot of the book talking about systems and how the various parts of systems are interconnected and all have influence on each other. So a good example of this is, in the real world, there's actually a surprisingly few number of people in between, say, a person living in London and a random person living in, say, Aberdeen. If you ask somebody how many friends of friends would be in between two randomly chosen people say, oh, maybe 20, 30, 40, I have no idea. It's something like 6 or 7. So a person in London will know another person, who will know another person, who will know somebody else, who will know somebody else, who will know somebody else, who has met that random person in Aberdeen. So the world is actually a lot more interconnected than we think, and obviously social media in recent decades has made this much more so. But our behaviour can have ripple consequences. What we do is important, how we operate is important, what we give is important, because you influence other people who are then influencing other people, and then they're influencing other people. So your reach, your potential to positively influence the development of the world at large is larger than people realise. And it goes back to chaos theory, because it's small little things can actually give way to much larger things. So it's an interesting book. Do check it out. I would say that I think Charlie Munger was right in his belief in consilience. Charlie Munger very much believed in a multidisciplinary approach where we learn the basic concepts, the important concepts, the main concepts from all of the different areas of biology, physics, statistics, human psychology. So we don't just have like one way of looking at the world. You're able to look at the world with a diverse toolkit. He kind of calls it the Swiss Army approach, Swiss Army knife approach. Lots of different tools, ways of viewing the world. So you're able to piece together all of the different influencing factors, and even if they're small, they might have knock-on effects. There might be positive feedback loops. He talks about how life can be viewed as a positive feedback loop that kind of feeds on itself. And the book is called Deep Simplicity, because there might be a simple algorithm, might be a simple formulae, but because it's feeding on itself, it's influencing itself, you can produce these runaway effects. And he gives many examples of this in the real world. So just wanted to talk about the book today, because the main substance of the book is genuinely fascinating and very much pertinent, because it's all around us. Little things that could happen, and obviously the way we operate, we try to minimize risks, minimize adversity. To some degree, we can't completely eliminate negative things from happening, because the world largely, a large part of it is outside of our ability to control and to see it. And this is what makes life so fantastic and interesting. But being aware of it can just make you a little bit more at ease, because a lot of anxiety is caused by first of all, avoiding uncomfortable circumstances too much, because you become a little bit too sensitive to chaos and to uncertainty, but also just being aware that the world is this way. It can be liberating to some extent, because you just accept there's a lot we don't know, there's a lot we can't see, and to marvel at the beauty, the spiral galaxies. He talks about fractals quite a lot. So like if you take a leaf resembles a tree at large. A tree just looks like a very large leaf. And the shape of a leaf and a tree, in his view, John Gribbin's view, has been caused by simple formulae, which is operating at different scales. And there are many examples of this, of fractal shapes. But I'll leave this video. It's been 21 minutes, quite a long time. Hopefully you found this video interesting, and might have encouraged you to read the book, which would be fantastic for me. Thanks for watching, and see you again soon.